With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Equivalent resistance across the terminals of source of EMF 24 volts for the circuit shown in the figure is. Okay, so we have to find out the equivalent resistance across this 24 volt EMF source. Okay, so now we can see that we should reduce this circuit. Okay, so we can reduce this circuit as we can see that, let me explain you, these two are in parallel. Okay, we can clearly see that these as the current goes here, okay, then it goes here also. So finally we can see that these two are in parallel. Okay, now we can also see that as current will go here, okay, from here it will go here, then moving forward the current will go here and then here. We can see that current separates here and finally meets up to it at this point. So we can also say that these two are also in parallel. Okay, so let us reduce this two. Let us find the equivalent and move forward. So if we find the equivalent of this one, let us make it R equivalent 1 and let us make them R equivalent 2. So R equivalent 1 will be, they are in parallel, so 10 into 15 upon 10 plus 15, which will be 150 by 25, or we can say 6. Okay, and similarly for R equivalent 2, it will be 8 into 8 upon 8 plus 8, so it will be 64 upon 16 or 4. So now let's redraw this circuit. So after redrawing, the 24 volt will be same, and we have seen that these two are connected in parallel, so we get a equivalent resistance, okay, with value of 6 ohm. Okay, it is 24 volts only, and then this 4 ohms remain constant as there is no combination regarding this, and from here we can see that there 6 ohm remains constant, and this 4 ohm, this becomes 4 ohm, okay, as it is R equivalent. And now we can see that this 6 and this 6, let me write this also, it is of 4 ohm. Okay, so now we can see that they both are in series, okay, and these two are also in series. So let us find their equivalents and arrange them in a circuit. So for their equivalent, it will be 6 plus 4, as they are in series, it will be 10 ohm, and let us make it R equivalent 3, and the fourth R equivalent will also be 6 plus 4 is equal to 10 ohms. So now if we redraw this circuit, we will have this 24 volts as it is, but we will have a connection of 10 ohms here. Okay, let me write it more clearly. 10 ohms here and 10 ohms here. So now we can see that as current goes from here and it divides into two parts, and then again it reaches this point and then enters the battery, okay, of 24 volts. So now we can see that these two 10 ohms are in parallel. So if they are in parallel, so we will find the final R equivalent, which will be equal to 10 into 10 upon 10 plus 10, which will give us a result of 100 upon 20, or we can say 5 ohm. So 5 ohm will be the correct option. So option 3 is the correct.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.